Good day everyone, I am Arnaiza Fulo and I will be discussing you about the Engineering Cementitious Composite or also known as Bendable Concrete. Bendable concrete is a special type of concrete that can take bending stresses. Here, I will show you how this concrete undergoes deformations without any failure sign such as breaking and scaling. I will also discuss with you the different properties of this concrete that make it bendable. But first of all, let me discuss with you the importance of this topic. Um, Concrete is mainly used in constructions and in civil engineering as it provides durability and its fire resistance. However, the problem with ordinary concrete is that it becomes fragile when it cracks due to heavy loading or usually earthquakes. It is important to study this topic to lessen the risk of collapsing building and other infrastructures, especially in areas that are prone to earthquake. Um, ECC or Bendable Concrete was developed by Professor Peter Lee at the University of Michigan in 1990. The thing that drives him to this idea is that normal concrete is brittle and rigid, which commonly causes catastrophic failure when strained. So, he composed ductile concrete by reinforcing it with a polymer fiber. ECC elongates without fracturing due to the interactions between the fiber, sand, cement working in the matrix that bind everything together within the material. In addition to reinforcing the concrete with fibers also act as a ligament to bond it more tightly. The design of cement matrix with special ingredients make it more compatible with the fibers and increases its flexibility. Ordinary concrete is designed to resist cracking, but bendable concrete is designed to crack only in a carefully controlled manner. As you can see here, fibers do not stop the crack from forming, but they hold the crack. When a crack forms due to the excessive loading, fiber within the concrete matrix will absorb the tensile stresses in any directions, and each fibers maintain the crack small until it reaches its minimum band. Now, let us move on to the compositions of the ECC. Well, bendable concrete is composed of all the ingredients of traditional concrete, but instead of using coarse aggregates, they use polymer microfibers to increase its ductility. Basically, it contains cement, sand, water, fly ash, superplasticizer, and of course the fibers. Process of making bendable concrete is um, adding sand, gradually adding sand, cement, fibers together, and then adding 50% of water and plasticizer, and then gradually mix them until they reach their homogeneous states. There are different types of polymer fiber that can be used in creating a bendable concrete, but the two widely fibers that are used are the polypropylene fiber and the polyvinyl alcohol fiber. The polypropylene fiber is a kind of polymer materials with a lightweight, high strength, and corrosion resistance. Um, the crack resistance of the concrete can be improved by adding the polypropylene fibers because it optimizes the pore size distributions of the concrete. We also have the polyvinyl alcohol fiber. Um, The polyvinyl alcohol fibers is covered with a very thin slick coating which prevents the fiber from rupturing. Um, this coating makes the fiber stronger, and because of this coating, this fiber hold the concrete much stronger and much longer than any other fibers. So aside from that, PVA is a monofilament fiber, which means that they disperse throughout the mix and create multidirectional network in the materials. Nextly, let us have a comparison between bendable concrete and ordinary concrete. Bendable concrete has a strain capacity in the range of 3 to 7%, while ordinary concrete only has 0.01% strain capacity. Bendable concrete is ductile in nature, while ordinary concrete is brittle in nature. The crack that appears in ordinary concretes are grivet-type cracks, which these cracks increase in width as they grow longer, while the cracks that are formed in bendable concrete is the steady states or flat cracks. The width of these cracks remains constant regardless of its length. So, therefore, ECC deforms much more than normal concrete, but without fracturing. Now let us have a video here from the University of Michigan, where they test the ductility of the bendable concrete. So let us watch this video first.
Each year, an average of more than 2 tons of concrete is poured for every man, woman, and child on the planet. That makes concrete by far the single most utilized engineering material on Earth.
Concrete is a very, very good construction material for many reasons. It's relatively inexpensive. It can be formed into different kinds of shapes relatively easily, and its ingredients are widely available. The one shortcoming is the brittleness of this material.
In an experiment conducted by University of Michigan Civic and Environmental Engineering professor Victor Lee, the steel reinforcement rod embedded in this structural model was pulled upward. The concrete in which it was anchored shattered. The outcome was much better for Professor Lee's bendable concrete, called Engineered Cementitious Concrete, or ECC.
This is what we call plastic behavior. So the material provides a give under very extreme loading instead of fracturing into pieces and still hold the load.
ECC's bend but don't break approach can result in safer buildings.
That's how we got started in this work, to enhance structural safety under extreme loading, such as during a major earthquake event or during even man-made disasters like bomb blast, for example. We would like to keep the occupants safe.
Another test, conducted by research fellow Mo Lee, measures bending loads on a horizontal span.
This is a normal concrete specimen under bending load. So here on the bottom of the specimen will be under tension, and the top of the specimen will be under compression. You can see that it has very sudden failure, which corresponds well to the catastrophic failure mode of concrete structures.
Achieving catastrophic failure on the ECC sample takes 4 times as much force, and it displays over 300 times the ductability, or bendability, of the standard sample. And while failure for the standard sample means snapping in 2, the failed ECC stays in 1 piece. The secret lies in adding coated microscopic fibers that work together to share the load.
You can see those tiny little cracks formed here. Those cracks are so little that they are as tight as human hair.
According to postdoctoral research fellow Aaron Sekulich, there's a side benefit to trading one big crack for many smaller cracks. Turns out, bendable concrete is also self-healing.
This is the kind of crack that you would see in regular cement or regular concrete. It's fairly wide. And then down here is a crack that started out much smaller and it was able to heal much better. All concrete has some capacity for self-healing, but in normal concrete, that doesn't work because the cracks are all very, very wide.
And what kind of exotic chemicals does it take to heal these micro cracks?
Water and air, which fortunately, especially here in Michigan, we have plenty of both.
And like any place that has 4 seasons, Michigan has plenty of cracks and potholes on roads and bridges. Part of the problem is that roads are made of a combination of concrete and steel, and when steel rusts, it expands, a process that can be accelerated with a small electrical current.
120 hours after the current started, the concrete cracks, and it cracks to a very severe extent so that basically it just fractures the concrete. You can see the corroded steel inside. This is basically what happens often on a bridge deck where steel is corroded because of the presence of water and de-icing salts.
And while standard concrete failed after 120 hours of the accelerated corrosion experiment, the ECC sample remained intact after 3 times as much exposure.
Here's a very small micro crack showing up, and here's another one where the corrosion material comes out. So it experiences damage because of the corrosion of the steel, which expands around it, but it accommodates that expansion by being able to plastically yield.
So for states with only 2 seasons, winter and construction, just how long might a road made with ECC last?
What we are hoping to achieve with this newer material is to extend the service life to as much as 100 years.
Concrete that bends, heals itself, and makes buildings safer, and roads that can last 100 years. What could possibly be next? How about smart roads that could tell you how they're doing?
With the ability of self-sensing, the structure will always know and report its condition so that repair can be done only when and where it is needed.
An infrastructure that's safer, more durable, and more sustainable. Sounds like a good road forward.
So that's all, like what they have discussed in the video, and like what they have shown in the video. Bendable concrete can stress or can carry a heavy load, and it is also a self-healing concrete. It is because bendable concrete forms small crack. So with the presence of CO2 and carbon dioxide, those cracks can heal naturally. Now let us move on to the advantages and the disadvantages of the bendable concrete. So the advantages of the bendable concrete. Bendable concrete has the ability to bend like metal. It is more stronger, more durable, and lasts longer than the ordinary concrete. It is not brittle because it's ductile, so it is not brittle like a glass. It does the fact about this bendable concrete is it is environmental friendly because it does not emit that harmful gases as compared to original or ordinary concrete, and it also has the ability to change its shape. So let us move to the disadvantages. Well, it has a high initial cost as compared to conventional concrete. It requires skilled labor for its constructions. It needs some special type of material which can be difficult to find in some area, especially the fibers. Its quality depends upon the material used and the condition under which it is made. Well, like what I mentioned before, there are different types of polymer fibers, actually fibers that can be used in making bendable concrete. It can be steel fiber, carbon fiber, and like what I discussed, the polypropylene and the polyvinyl alcohol. And those different types of fibers also have their own properties, and the quality of the concrete, of course, depends on the properties of the fiber that used in the concrete. So that is why it depends on the material, and it also depends on the conditions which it is made. So that's all, and thank you for listening. I hope you learned something from my presentation, and I want to give credit to this link, to this website, because this is where I get my pictures and all in my presentations. So thank you, and that's all. And once again, I am Arnay Zafula of CE1C, and that is my special topic, which is a bendable concrete. Thank you.